The cosine ratio. So cosine ratio is another one of those trigonometric ratios that lets us compare the sides and angles of right angle triangles like this one. We can check that this has that right angle in the corner, that little box. And it lets us find various sides and angles. So cosine ratio looks like this. It's got cosine of theta. Remember that theta is a Greek letter. Just means an angle, just how we use it in math. And that equals the adjacent side. I write that as ADJ over the hypotenuse, which I write as HYP. Okay, that's all well and good, but what's the adjacent? What's the hypotenuse? Well, let's take a look. So hypotenuse, we'll recall, if we look at the right angle of a triangle, so again, that's the corner that looks like a square. Okay, we look all the way across from that angle, so we imagine that it goes out from this corner out to the side here. This longest side of the triangle, that is our hypotenuse. Okay, HYP. Okay, now if we assume that the angle for this triangle is, say, down in this bottom right corner, so that's our angle theta. Remember, theta just means any angle. If we look across from that one, well, that would be our opposite side, but if we look right beside it, right beside this angle, so the side that is adjacent to the angle, that's why we call it adjacent, but is not the hypotenuse. So the two sides that touch the angle are the hypotenuse and the adjacent. So this one must be the adjacent since the other is the hypotenuse. Now, adjacent is a tricky one to find sometimes. So what I often like to do is I like to find the opposite first. I like to find the hypotenuse next, and then I find adjacent at the end just because it's the last one. It's the only one that's left over. So if you find it difficult to figure out, well, which one is the hypotenuse, which one is the adjacent, just find every other side first and then find the adjacent. Okay, so with that in mind, there are three kinds of questions that we can use cosine with, and we're going to take a look at all three. So let's get a clean page here so we can take a look. So let's say we have a triangle that looks a little bit like this. So it looks like that. Got our square corner up in the left there. We have 54 degrees up over here in this corner. We've got a side length of 13 up here, and let's say our unknown is over here. Okay, so first thing we do in every single trigonometry question from here to forever is to label our sides. So we can see that across from this right angle, right across from there, that'll be our longest side, our hypotenuse. And if we look, there are two lines that touch the angle. We know that this one is the hypotenuse, so that must mean that this one is the adjacent. Okay, so we have adjacent, we have a hypotenuse, which means that we can use cosine. Okay, so cosine of theta equals the adjacent over the hypotenuse. Okay, so from here, it's very similar to other trigonometric questions. So because it's so similar, I'm going to show you a little bit of a shortcut this time. Okay, so we fill in all the numbers that we know. Cosine of the angle, which was 54 degrees, equals the adjacent, which is 13, over the hypotenuse, which is x. We don't know what that is yet. We'll be figuring that out soon. Okay, so here's the shortcut. Instead of doing the math that we did when we looked at sine, we can just get to the end of it. We can just skip the math because we know how it's going to work out. So all you do is you take this guy and you take this one and you switch them around. Okay, now we showed how that worked in the last video. So this time we're just switching them around, and we'll just take the result here, which is that x equals 13 over cosine of 54. Now remember, we're not just switching the 54, we're not just switching the cosine, we're switching the whole thing, cosine of 54. Okay, now once we're here, we can just solve everything since everything on the right is solvable. So we have x equals 13 divided by, and then we use our cosine on our calculators, which again, remember, is going to be either you enter 54 and then you press cosine, or it's going to be you press cosine and then you press 54, and again, that just depends on your calculator. Unfortunately, I can't figure that out from here. So I'm going to stick that in my calculator, and I get 0.5878. And again, I'm just rounding to that 4th decimal place. Okay, so once we've got that, we can just take our 13 divided by 0.5878. Okay, so that'll be x equals 22.1. Okay, and that is our final answer for this question here. Okay, so that's looking at solving for the hypotenuse. This is our process for solving for the hypotenuse. So let's continue and look at solving for the adjacent side. Okay, so fresh page here. Okay, so let's say we have a triangle that looks a little bit like, we'll make this one look a little bit different. It'll be like that. Okay, we're going to put our right angle down here. We've got 17 degrees as our angle over on this left side here. 18 as our side length up here, and we'll stick our unknown down here. Okay, so let's quickly label our sides. You know, the right angle is here, so we go all the way across. That'll be the hypotenuse. The side that is touching the angle but is not the hypotenuse, right down there, is the adjacent. So that means that we can set up our cosine question here. So cosine of theta equals the adjacent over the hypotenuse. And we start plugging in values here. So cosine of, not 54, that was the last question, 17 degrees, there we go, equals the adjacent, x over the hypotenuse, 18. Okay, so now we just have to get x on its own. So to get rid of this divided by 18, we have to do its opposite. The opposite of divide is multiply. So we're going to multiply by the thing we want to get rid of. So we're going to multiply by 18. Okay, for that reason, these two will cancel since it's 18 over 18, which makes 1. And then we just do the same thing to the other side because math is fair, and whatever you do to one side, you have to do to the other side. So if I were to rewrite this just for simplicity's sake, it'll be 18 times cosine of 17 degrees equals x. Okay, now everything on the left is solvable, so we can start solving. So we should have 18 times the cosine of 17, which is 0.9563. And remember that your calculator should be in degree mode. So not radians, not gradians, degrees. Otherwise you will get the wrong answer and you won't know until the end. Okay, and then we just multiply this together. So we get 18 times our cosine value there, which will give us 17.2. Okay, so that one's pretty simple. Just that one little step in there to make the equation work, and then just solving it on the calculator. Okay, so that's how to solve for both sides, the hypotenuse and the adjacent. Now we're just going to look at how to solve for the angle. And solving for the angle in these trigonometry questions usually looks pretty similar. Whether you're using sine, cosine, or tangent, they look pretty similar no matter what you do. So we've got an unknown angle up here. And then we have a 43 side length over here, a right angle in the corner over here, and a 31 side length over here. Okay, we quickly label these. We've gone over this. So again, it's across from the right angle. We have our hypotenuse. And then touching the angle but not the hypotenuse, we have our adjacent. Okay, so then we get our equation set up here. So it's the cosine of theta equals, and then we have our adjacent over hypotenuse. And again, I like to write out this equation every time just so I don't get lost. We fill in all the things we know. We don't know theta, so it's cosine of theta equals the adjacent, which was 31, over the hypotenuse, which is 43. Okay, one thing you should note here, you'll know that you have these in the right place when this number is smaller than this number. Okay, that's because cosine of theta, when you're working in degrees, cannot be greater than 1. Which, if we think about it, makes sense since the hypotenuse must be the longest side, which means this one must be bigger than this one. Okay, if you get a value that is greater than 1 and you try to put that in your calculator, and on the last step that we'll do here, it will fail. You'll get an error. unless you were in the wrong mode. Then you might get an answer. It would just mess you up further, so don't do that. Okay, so 31 divided by 43 gives us our cosine of theta, cosine of theta equals 0.7209. Again, keeping those 4 decimals there. And finally, we just have to get rid of this cosine. In math, when we're trying to get rid of something, we just use its opposite. The opposite of cosine is a little thing called the inverse cosine. Okay, inverse cosine and cosine cancel. And then we just have to do the same thing to the other side. Now I'll remind you that it might not look like that on your calculator. It might also look like acos or arccos. They're the same thing. It's just backwards cosine. Okay, so now we're just going to take that value. We're going to take that value and we're going to do the inverse cosine on it. So we end up with theta equals 43.9 degrees. Okay, which is our final answer. Okay, so very similar to sine, and it will be very similar to tangent when we look at that one as well, but that's how to solve for the hypotenuse and the adjacent and the angle with cosine.